Assalamualaikum. My name is Muhammad Fazli Muhammad Tajuddin under program code EE750 and supervised by Dr. Muhammad Najib Muhammad Hussein. My research title is Integrated Stability Model of Solar PV Interconnection by using PSSE software. So for the introduction, research and study the development of PV plant for dynamic stability assessment using PSSE software. Study the stability and the behavior of PV plant into grid interconnection by developing 118 bus and 30 bus system in PSSE software. Observation CCT of the system for occurrence back to its normal condition. The simulation result obtained by using user model to generate model as the one proposed by the WECC and generate type for PV generator. So for the first objective is to design and integrate PV solar power with convention plant system by using PSSE software from scratch. Through the research, two design has been developed, which is the T-bus system and 118 bus system has been tested and stable through the simulation. For the second objective is to perform stability assessment of interconnection for large-scale solar PV to the distribution system. The PV system has been injected by disturbance, which is by tripping and three-phase fault has been applied. The stability assessment is needed in order to identify the system model is suitable to face the disturbance. So for the third objective is to study the dynamic behavior of the system with solar PV injection by applying disturbance to the system. The behavior of the PV generator has been observed after the dynamic simulation process. The system back to its normal condition after oscillate few seconds show that the system is stable. So for the scope of the study is identify possible PV generation in order to get back to its stability of the system by review the previous study that related to stability of the PV connected to grid system and apply to the system that has been modeled in this study. Stability assessment of the solar PV plant will be done, and the frequency, voltage profile and generator reactive power output, while the behavior of the PV plant will be also in the different penetration level where will be performed in that has been performed in dynamic stability analysis. So for the literature review is related to the power system stability, which is power system stability ability of electric power system for a given initial operation condition to regain a state of operating equilibrium after being subjected to the physical disturbance. If the system is unstable, it will result to the progressive decrease in bus voltage. So solar photovoltaic grid connected to PV system. Grid connected to PV system with the generation of energy from sunlight through solar PV system, which connected to the utility. The grid connected to the PV consists of solar panel, solar inverter, a power condition unit, and grid connecting equipment. Transient stability involves when each last disturbance is subject to the system. The difference of the transient stability and the dynamic stability, where the dynamic stability ability of the power system to maintain stability under continuous small disturbance. For the dynamic stability study is carried on in order to calculate the response of the power system in the specific time of set of incident. The dynamic stability study is carried on to determine the behavior of the power system when fault is applied. The dynamic analysis will be performed to investigate the response of the system after fault has been applied. Three-phase fault. Due to the higher PV penetration level, the system shows different behavior than the system with no PV when fault has been applied. The frequency and the voltage oscillation in the system with PV generation are well damped than the case with no PV where it's poorly damped. So for the methodology start, we construct bus system. So for the methodology for this research, to get the result in the PSSE software is by construct the bus system, run load flow analysis, convert data to dynamic data file, then read the dynamic data file. After that, run transient stability data, apply disturbance to the system. After we obtain the graph, if the system is stable, yes, we end our process. If not, increase fault clearing time gradually until we reach the system is stable. If not, we need to reconstruct back the bus system and adjust the data in the bus system. So for the data collection, 118 bus system with the WECC generator, all the data and the graph show the when applied to the disturbance at 0.1 second, the generator oscillate and backs to its normal condition, show that the system is stable. So for the 30 bus system, also same. When the fault has been applied, the generator oscillate and backs to its normal condition at take less than 5 seconds to back to its normal condition, which show it also stable. So for the fixed irradiant 30 bus system with generic type 4 PV generator with fixed irradiant, show that when the sudden irradiant drop, then back to its normal condition, show that the generator is oscillate, which is show unstable but back to its normal condition in a few seconds, less than 5 seconds. So for the 30 bus system, same with 30 bus system with generic type 4 PV show for the irradiant drop, show that when the irradiant suddenly drop, the generator oscillate a few seconds and backs to its normal condition. So for the status data collection for 118 bus system is about 85% and 30 bus system about 90%. For the data collection, almost completed. So for the status of publication, all the publication have been published, and for the Scopus one also is published, which is IGECE, and also for JEESR last year has been published. So for the status thesis writing, show that chapter 1 is completed, chapter 2 95%, chapter 3 95%, and chapter 4 85%. And maybe this semester we proceed to complete thesis writing and submit the intention form before this semester end. Thank you. That's all from me.